This webinar will focus on what is Kubernetes and how it can help developers in speeding up their deployment tasks. If you don't have a basic knowledge of Kubernetes or application architecture in general, not to worry, as we will try our best to deliver this webinar as simple as we can. Okay, so what can you expect from this webinar? This webinar is targeted towards developers who are interested in Kubernetes, but has zero knowledge on what Kubernetes is, or if this is the first time they hear of Kubernetes. Students can also benefit from this webinar, as they can have a head start on how the industry manages large applications in production environment mainly. For the general public, it is also beneficial for you also, especially those in the IT industry. And okay, now let's get to know the presenters. My name is Iman Izzat Farhan bin Muhammad Nur Azman. I am an operations officer under research and development in ITPSS Niremberhad. I am a computer science undergrad from University of Chester. My experience so far was as a full stack developer using .NET MVC. But my focus currently is in ITPSS is blockchain development. The next speaker, the second presenter, is my fellow R&D colleague and operations officer, Muhammad Hanif bin Jumat. Hanif is an information security graduate from UTB and an undergrad in computer network and security, also from UTB. He will dive deeper into Kubernetes later on in this webinar. Oh yeah, he is also a certified Kubernetes administrator. He is well-versed in application architecture and network security, and Hanif also had participated in local and international competitions and achieved a special awards from BICTA in R&D and IoT, Internet of Things. Right, moving on to the agenda of today's webinar. First, we will talk about evolution of applications from monolithic to microservices architecture. And then next, we will talk about what is Kubernetes. Basically, it's an introduction of Kubernetes. And then we will see how much Kubernetes is being used in the industry through surveys and statistics made by other companies in the world. After that, we will compare Kubernetes and Docker to know what their differences are. And we will also look into the strength and shortcomings of Kubernetes. Then we will dive deeper into Kubernetes architecture and its features. And by the end of this webinar, we can look into how ready you are for Kubernetes and what Kubernetes is and what is it not. Okay, let's start on our first topic, which is the evolution of applications. How application architecture and infrastructure evolves throughout the time. Traditionally, how an application's infrastructure was set up was with the monolithic architecture in mind. But what is monolithic application? It is when an application was built on single physical server, where all the components such as the front end, back end, etc. are contained in that server. As you can see, the red pentagon represent the physical server, and inside the pentagon are the services or components of the application. Basically, the application is hosted on premise within the organization. Next to it is microservices. What is microservices? It is when each of the application services or components are decoupled from an on-premise hosting to cloud-based hosting. Each component will have its own cloud server represented by the red pentagon, hence deployment activities will not affect the other services. Next, I will break down each type of architecture, starting with monolithic application. As I've explained from the last slide, each of these applications services are contained in a single server as represented in this diagram. This type of architecture works well in the early life of the project for the ease of code management and also deployment. But if we want to scale individual components of the application, this becomes hard as the services are coupled with each other. Deployment might be easy and straightforward, but even the smallest changes to the application, we will have to redeploy the entire application. For example, if we were to make changes to the front end and the changes made are significant enough and require restricted access during the deployment process, we would then have to take down or restrict access to the whole physical server. Basically, if we were to make changes to the front end, right, as represented with the orange circle, we would then have to take down the backend API database and the other services connected to the application. Yeah, because it is in a single physical server, right? And moving on to microservices applications. So how does it work? As you can see from the diagram, the red pentagons are surrounding each of the components. So what does it mean? As I've explained before, each of these services are hosted on a different cloud servers, decoupled from each other. What are the advantages of designing an application this way? As I talk about monolithic disadvantages, excuse me, from the last slide, one of it is scalability of the application. With microservices, scaling of applications are easier due to it being decoupled from each other. What do I mean by decoupled? Each application is in its own server, thus we do not have to redeploy the whole application, only the desired service. Although deployment is a tad more complex, but with the help of container managers such as Kubernetes, developers can deploy the application without having the need to take down the whole application. They can also deploy multiple times a day, even thousands of times for large projects. So where does Kubernetes comes into play? Well, in this diagram. So if we were to update this front end service, we can use Kubernetes to deploy whatever latest changes we have made for front end. The same goes for each of these services. Kubernetes is basically a tool to manage microservices. So what is Kubernetes? Moving on to the introduction of Kubernetes. What is it and what does it do? Kubernetes, or K8 is an open source system to deploy, scale, and manage containerized application anywhere. The word Kubernetes originally comes from Greek. It means like I think pilot. So Kubernetes acts as the pilot for this containerized application, which are the passengers, basically. Yeah. So why do we use Kubernetes? It is to help speed up deployment of applications by automating container operations. Scaling of applications is easier. It saves operating costs by not having a lot of physical servers to host each applications. By having a lot of physical servers, you also increases the maintenance cost of each of the servers. Okay. So who created Kubernetes? who comes up with this system, with this application. Google open source Kubernetes in 2014, but it is currently maintained by Cloud Native Computing Foundation. So because it is open source, it is very, what do you call this? Never mind, moving on. How is it being used? Kubernetes manages containerized applications easily. It can be used alongside Docker, which is a popular software used to containerize applications. So what is containers? I've been mentioning about containers for the past few slides. So what is it? Containers allow developers to package up an application with all the parts it needs, such as libraries and other dependencies, such as and ship it all out as one package. One of the software that can do this is called Docker. But what is Docker? It is a software used to containerize application, basically. But it is also possible to not use Docker to containerize application. But using Docker will speed up the containerization faster, easier, and safer. So how is it being used with Kubernetes? Kubernetes manages these containers created using Docker, such as automating its deployment, load balancing, reviving the failed containers, and etc. Then let's take a look on the usage statistics of Kubernetes. From VMware State of Kubernetes survey in 2021, 68% of respondents are using Kubernetes in production environment. 96% are either using or evaluating Kubernetes from an annual survey conducted by CNCF in 2021. Also from the same survey, currently there are more than 5 million developers are using Kubernetes, 5.6 million to be exact. Next, statistics. 70% of developers are using Kubernetes from a report by Red Hat in 2022. Then from their last year's report, which is in 2021, 85% of IT professionals agrees Kubernetes is an important tool. From Portworx 2021 Kubernetes adoption survey, 55% of respondents claim that their annual costs are cut down by 20% after implementing Kubernetes in their workflow. After going through all these statistics, we can see how important the usage of Kubernetes is in the modern time of application development. Not only it reduces costs by a significant margin due to less physical servers to be maintained, but it also increases efficiency of the developers. Then moving on into companies that adopted microservices. So who adopted microservices already? Many top companies in the world implemented microservices for their application. These three companies are some of the companies implementing microservices. I'm sure all of you know or heard of these companies before. These companies own applications widely used throughout the world that even you and I have used before. We're only Netflix lah, because Amazon and Uber is not available in Brunei, sadly. But due to this scale of applications being huge and very hard to maintain if they were to implement monolithic architecture, it is a no-brainer for them to use microservice as their applications architecture. Okay, next we will dissect Kubernetes with my colleague, Tuan Hanif. Silakan.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Taniman, for your presentation. So I'm sure you everyone already hearing about the terms microservices. So how is it connected with Kubernetes, with our topic today? So basically, Kubernetes is basically the tools that you use so that you can create microservices. So that's the differences between Kubernetes and microservices, and how the tools that we can use to develop microservices. So before we go further into Kubernetes, I need to talk about the differences between Kubernetes and Docker, because there's a lot of misconception, confusion between these two. Basically, they both are almost similar. They're used for building or delivering, scaling a containerized apps. But the difference is Docker, as you can see from the diagram, Docker is used for creating or sharing an individual container. But for Kubernetes, is actually on top of Docker itself. So it used to manage the Docker container in a way that it is clustered in Kubernetes architectures. Now, this is an example of a Kubernetes architecture. I know this can be very intimidating, but we will try to explain this as simple as possible. Just to let you know, this is just some of the components of Kubernetes. Of course, unfortunately, due to the time constraint, I will not be able to explain everything in details. Now let's go further. So in Kubernetes architecture, there are two important components that makes up a cluster. The first one is control plane, and the second one is the node. So basically, control plane is used to manage the clusters and to manage the node. And the node itself is actually the application that you are deploying. So any type of application, so front-end application or the back-end application, it will be stored inside the node itself. And as you can see, there is node 1 and node 2. Node 1 is actually a replication of node 2. So this 2 is actually the same. So let's say, for example, node 1 down, then node 2 can still available and work as usual. But in this architecture, let's say that if the control plane is down, then everything will not be working because there's only one control plane to manage the architecture. That's why in modern microservice architecture, the best practices is of course not to have one control plane, but to have multiple control plane and also to have multiple nodes at the same time. Next, let's move on to the next component in a control plane. The first one is, let's look at into etcd. So etcd is a key value store. You can sort of like JSON file. So it's used to store a Kubernetes backing store for all the clustered data. So basically, what's that? What is that mean? What it means is that etcd is just a database of the cluster information. That's it. So, and when we're talking about Kubernetes, we're talking about a distributed system. So etcd is the tools. It is a distributed, reliable key value store for storing most of the critical data in a distributed system. And another important thing in etcd is the PKI. Everything has its own certificate. We have server cert, client cert. So what this gives into Kubernetes is that it gives a secure communication throughout the kube network. So we need a way to basically you can think of Kubernetes as a whole one network that can communicate with one another. So for them to communicate with one another, we need a secure communication between them, and using PKI, it can give a secure communication between them. Now let's move into kubectl, the API servers and kubelet. But before that, let's look into Cloud Control Manager first. As my colleague Iman has explained, cloud is very important nowadays, and most company they already shifted most of the application from on-premise into cloud. This is where Cloud Control Manager comes in. It helps with communicating with the cloud API. So the next thing that I want to talk is the kubectl. So kubectl, also some people call it kubectl, kubecontrol. But for this presentation, I'll be referring it to as kubectl. So as a developers or administrator, most of the time, the way that you will interact with all the Kubernetes network is through the kubectl. So from this kubectl, you'll be talking to the API server. The API server is the one that validates or configures the data for the API for Kubernetes objects that include pods, services, replication controllers, and so on. Probably will explain some of this in the later slides. But basically, the API servers, they're communicating with one another using REST API, which is secure by, if you remember earlier, by using the PKI, by using the certificate. And then the kubelet, basically from the developers, they're using kubectl from the API server and the kubelet. So this is how they communicate between the control plane and the node. So the node, each of the node, they have their own one that we call a node agent. Basically, kubelet is the agent that will handle the anything on the Kubernetes node. And another questions that often how can we create the Kubernetes cluster? Basically, there are two ways that we as a developers can create a cluster using command line tools. There's two methods. The first one is imperatively, ataupun the second one is declaratively. So if you are familiar with Docker, you might have heard ataupun use the concept of Docker Compose. So similarly here, Kubernetes, you can get, create, list, or delete, update. Instead of Docker file, it is we're updating pods ataupun Kubernetes resources. Next, let's move on into the scheduler and the container runtime here. My friend has been mentioning a lot about front end and Nginx. So basically, where is it placed in? Container runtime is basically the Docker. The pod is the what we call the smallest and most basic deployable objects in a Kubernetes. So a pod, it represents a single instance of any running process in a cluster. So you can have multiple front end, or you can have multiple Nginx pod. So let's say if one Nginx pod down, the other pod will continue to work as usual. And the scheduler is the one, the scheduler in the control panel is the one that assigns the pod to its node. So any scheduling or queuing or any resources, it will be done through the scheduler. Next, let's move on into controller manager. Controller manager is the daemon, the background processes. Basically, what that embeds the it continue to if, for example, in robotics, in automation, there's a control loop in a non-terminating loop that regulates the state of the system. Similarly, in controller manager, it it watches the node 1, node 2, or the control plan to ensure that all the pod is always there, it always available, or the deployment, all the service, it always so that it always there. So the controller manager is the one that manages everything so that it is in a current state that we want or in a state that we desired. And some of the things, some of the Kubernetes resources, for example, services, we can use it to create a service. For example, if you want to expose a port or etc. If you want to deploy, if you want to create a deployment here, or if we can also create a volume so that we can, because Kubernetes they store data only temporarily, so you need a way to store the data persistently. So this is where PV or persistent volume comes in. There's also jobs and also network policy to ensure that all the network, all the policies, all the rules in the Kubernetes work as usual. So last but not least is how the user view the contents. This is where the kube proxy comes in. It maintains the network rules on the nodes, so it works with the network policy and so on. So this network rules, it allows the network communications to your pods from the network session inside or outside of the cluster. So this allows you to communicate, this allows the users to access the application stored inside the node. And this is, you can think of kube proxy macam in reverse proxy in Nginx ataupun Apache that exposes the internal application to outside users. Now, I'm sure by now you have noticed one keyword that I've kept on repeating, which is availability. So if you look at the strength of Kubernetes, most of them is targeted into a system that are always available for users. So it capable in load balancing itself. So whenever a pod down, or let's say a node down, or even the control plane is down, there's always a way for it to self-heal itself. So of course, if there is another pod or any replica available, so again, it's up to how you design your system. And last but not least is it is easier to scale up your operations. So let's say in certain day, there's not a lot of people accessing your website, so you probably can scale down your system, scale down your Kubernetes, and this can save you some money. And after, when in some certain days there's a lot of people using your application, then you probably can increase or scale up the system. Of course, all good things has its own shortcomings. The same thing goes for Kubernetes, especially for students, even new graduates. You may find Kubernetes is a huge topic, and it can be very challenging topic to learn and master. And I think the best way for to learn Kubernetes, I recommend you to look into their documentation. Everything is there and it is free. And the good thing is now there's a lot of free resources on YouTube, and you may want to check it out. The second thing is Kubernetes is very difficult to set up. There are a lot of considerations that you need to look into. even before you start using it. For example, you need to look who will be using it, the usage requirement, the architecture that you'll be using, how many nodes that you need, what is the level of availability that you want, the network design, and so on. And only once all of this Kubernetes configuration is configured correctly, then you can see how complex a Kubernetes can be. And this shows in my next point, which is complex management. Once you realize that each of the major components of Kubernetes, or even the pods, the nodes, the kubeadm, the kubelet, is its own version, which means that you need to maintain and update each one of them to ensure that the Kubernetes or even the application, the pods, so that it remains up to date. So this can be very challenging, it can be very complex without the appropriate tools. Now the question is, when is the right time for you guys to, or any organizations, for you to use Kubernetes? First, you need to look at your application and answer the question, is my application monolithic or microservices? If it is designed specifically for monolithic architecture, then of course Kubernetes is not for you. But if you're developing a system with huge and complex architecture, that maybe it span multiple cloud servers, then Kubernetes is probably the best answers. And secondly is when you need a high availability. So let's say if the system, let's say you use on internally is only used by 10 people, then Kubernetes is probably not needed, right? But let's say your application that you're deploying is used thousands of people and require SLA, service level agreement yang 99.99%, then you can consider Kubernetes as your options. Lastly, Kubernetes is only for production. You can use, of course, you can use Kubernetes for local development, but why would you complicate yourself during development period, right? It's not advisable because of its complex management and difficulty to set up. I mean, even if you look at the website, the Kubernetes website, it will say specifically production grade container orchestration. Why? Because Kubernetes is designed for production, not for development. So basically, to summarize what you've learned from our webinar today, my colleague has shown what is the introduction on Kubernetes, and I have explained the architectures of Kubernetes, and at the same time we have shown the strengths and weaknesses of Kubernetes, and when is the right time for you to move to Kubernetes. So hopefully for developers who have zero knowledge on Kubernetes, you guys can learn some introductions on Kubernetes. And of course for students, we hope this can be beneficial for your study, I mean even in the future, because we do believe that Kubernetes will be very beneficial, and I'm sure there's definitely job opportunities there.